Okay. Okay, let's see. Where is this? Utah. Utah, looking very good. Bonefield, South. Nice. Gonna visit it someday. This three. Looking at two, four. Okay. With this, okay. Let's start. Wait, what? Maximum product subarray. What is this? So you can generate all the subset, right? Subarray. Is it continuous? Okay. Is it continuous, right? So you have to do this, multiply by these. So only thing that we can explore right now is that right. So we start at 2, right? And it has negative number too, so the product of any subregnum guarantee to fit into 32-bit integer. Also contiguous. You start here, you can keep multiplying, right? So this look like a prefix tree problem, right? So you would have, you split them into 0 to 4, right? And that would be 0 to 2. Right, 3 to 4, right? And then 0 to 1. uh, 2 to 2, is that what it is? So, but what about 2, 3, 4, right? So let's just, I don't think that's what it is though. So you start at this, you multiply this, which is array of size right. So you start at 2. You wanna, you have to pick, right? You have to pick because it's contiguous, right? So you start at 2. You can have 2, 3. You pick 3, or you don't, you pick 2 and you don't pick 2, right? Which is 3, right? So now go to next. Let's give you 6, right? You go next. You also have 2 options. You pick 2, 3, -2, or you don't pick 2, 3, -2, right? You don't pick -2, right? So that means you can pick 4, right? So this give you what? -12. Largest product, right? So this give you 4. Right? We come all the way back here. Right? So this give you 3. Right? So in here you either pick -2, which give you -6, right? Or pick -2, or okay, or you pick 4, right? Which is 3, 4. No, you can't, right? Because it has to be contiguous. So we go in here, you click 4, and that give you negative 24, right? Okay, and then you go on wait, but also, right? Is it all the sub-array though? All sub-array, how do you generate them, right? It can be solved in ON. Largest sum. How does it deal with negative? Okay. Cardane algorithm. So this looks like a Cardane algorithm or something. Right. So does Cardane algorithm work? Or we just keep doing what we're doing here, right? So 2, 3 here, 2, 3 negative 2. So what are the sub-array that 3 can be part of? Can be part of 2, 3, which is this one already, right? So if we do this, 4 is 4. So then now we have negative 2. So this is negative 2. Right, we have to force to pick 4, right? Or not pick at all, right? This will give us negative 8, right? So should we even start a 3 at all? Because the outcome of this is like we see a number that greater than that already, right? So right, so we can start a 4 here and there's nothing to pick, right? Result cannot be 2. Oh, you can't have subsequence. Okay, so let's try this and we'll look at the Cardane stuff. Okay, so basically we would have product gonna be 51 10 max. Okay. So basically for I in range of num, right? So we would write a function do a pick right? So in the I, right, we would pick if I greater than length of num greater than or equal, you just return, right? So then we would pick I. We start with the 1, right? We pick I plus 1, B here, B multiplied by nums I, right? Or pick I plus 1. So you can pick 3 or you start at the next one, right? So be nums I, right? So if we greater than that, so basically right, something like that. So if we pick this, we start at 2, right? So either pick 3 or we start at 3, right? Right. So we would go in here. So basically if ans up I 0, then ans I equal to max of B, right? We can use ans as the initializer, right? Right, so start at 2 and we keep multiplying, right? So this, oh, let's just start with nums I here. If we pick I, if we pick this, then the product start with, if greater than that, return, make it -1 so that we know right. Okay, so then b multiplied by whatever this is, start at 1, right? And then we started this to be nums I, right? I think. And we either pick +1 or right, so we start with this, we pick the next one, or the start gonna be the next one, right? So this +1, right? We multiply by nums of I, right? So basically we can pick the next one because this is, if it's greater than, so if we get the last one, we shouldn't be able to pick them, and this is already 9 + 1, right? So if we len -1, right? -1, yeah. So either we pick one, right? This would be P, right? Right. So something like that. Let's do the cache one later. Let's see if it's working first. Right. Yeah, we see 6 here. 0, right? So basically here we gotta say so we start at 2 here, so on with 2 here, or right, less than B, right? Right, so we want to measure the max, right? So basically max product equal max of max products and answer I, right? Yeah, we probably have to do non-local, right? Right, something like that. Oh, we forgot to put it here. This is maximum product separate. right? So another thing that we want to do is we can see that after this, right, it's gonna be 2, 6, 12, 24, right? Negative 24, right? So if we keep going, so this we have 2, 6, 2, 0, 0, 0, right? Let's keep us 2, 6, oh, negative 1, sorry. Right, negative 1, and 2, 6, right, negative 12, negative 1, right, and then finally we got 2, 6, 12, 4, right, and then now we do 3 here, right? Is 3 gonna make it bigger, right? Then we should attempt that, right? So we could say if p multiplied by whatever this number is, right? If and I plus 1 and make it greater than whatever the already there, right? Then we go this, right? Same go for this, eh? Right, so we do that. Let's see. Right, let's see if this work. Oh, negative 2. I'll put negative 1. Right. Okay. Wait, hold on. Okay, we have to also do this case here. If right, here, right? So let's load a function date and say saying of IP, right? Update and np p date and in max product, right? Will be this one right here. Right, so this is basically AMP, right? So same as this one. Date AMP IP, right? What? And what's wrong here? 12. What 12? How does it become 12? Hold on. we do that, let's try this. Okay. If it is the last, right? Oh, we forgot to do the negative check here, right? But this could also be negative 1, right? And this is all, right? Okay. 4, right? Right. If and plus 1 and okay, so basically first plus 1 is not equal to negative 1 equal negative 1 or is not equal to negative 1 right? What happened? Okay. We only want to pick if the number that we already have the answer for is less than, right? So basically even if it's wait, hold on, let's put this to be none then, because chances that the negative 1 could also be a value, right? So basically if there's a number and even if it's none, right, we still go, right? Right, so if this is and we can compare number or not, right? It's either that or this, right? Here we go. I think if not and plus 1 or this, then we can pick where. Oh, okay, so now we gotta do this. So if the I gotta do this, right? Now it's wrong. Alright, so let's just hack a bit, right? So in the case that it has one number, right? So here we gonna go here, right? If it's greater than or equal to the last number. So if we ended up the last number, if it is none, or why is this wrong? We got 12 instead. Why? Which one make it 12? So we got 2, 6, negative 12, right? Oh. Okay, so let's see. Let's print the stuff that we pick, right? And see. Okay, 0, 2, 1, 6, good. 2 is negative 12, 3 to 6, negative 12, negative 48, okay. And we back down, right? So 6 here, right? Oh, this is negative. This become either you pick negative 2 and 4, or you not pick at all, right? So this make become 48. So this thing become, right? So basically at the last one here give us 48, right? So let's just match product and answer out, right? Right, so just do the print the entire answer. Okay, 2, 6, yeah, 12, 48, good. Then we can do 4, right? This is the last item. Last. $48. Okay, so let's do that. Do some debugging. Okay, so we go back to pick 4, right? Then why does it not go back to, this is negative 2. Why? Uh, 48, okay. Then you, so here you pick 4, you don't pick 4 at all, right? If you don't pick 4, you ended up with negative 12, so that's fine, right? Which is this, good. Somehow this is negative 2. What the hell? So this, you pick 4 or you don't pick 4 at all, or you become 4, right? So logic here is, if you don't pick 4, you end up with 4 here, right? So this is 4, right? So 4 should have replaced that 48, right? So if you pick, this means you pick all the way here and you got 48. But it would have been better if you pick 4 though, right? So we're missing something here. Right. Okay. Why is it negative 2 here? 0, 1, 2. Right? Either you pick the next one, you ended up with this amount, or you discard whatever you have and pick the next one, right? So basically, I think all of these can be I think this is probably fine, but I think 0, 1, 2, 3, right? So we got that. Where does this negative 2 come from? Right? So 2, 6, right? 2, 3, 6, 2, 6, 12, yeah, 48. What happened after 48? So oh, negative 2 here, right? So what logic does here? We run papers. How about paper here? Okay, so you have, what is this? 2, 3 negative. What is all this? Okay. You got 2, 3, negative 2, and 4. Right, so you pick 2, you start with 2, and it becomes 6, negative 12, 2, 12, 48, right? You either, oh, there it is, numbers. Alright guys, okay, so now what do we have here? Oh, because it should be the same as the ants. So match product equal to none or not, then if answer I, we run match product. There we go. Let's see. Oh, we just do not here. There we go. Let's see if this works. Okay, submit. Wrong answer here. $288. I get the 4. So 1, -2, 3, -4, -3, -4, -3. Okay. So how did they do it? So 1, -2, -6, -6, 24, what is it? Before multiply, let's just debug this. Do we ever got 432 somehow? Right? So how do they get 432? We do 20 on is 4032, basically 1. That's 864. And how do they get 432? Like assuming the negative number doesn't matter. Right? So 864 divided by 3. So we missed a 2 here somewhere. So we shouldn't pick 2 is what it's saying. 3, 4, 3, 3, 4, 3, 4, 3. This is stage 2, right? So basically somewhere 0, 1, 2, 0, 1, 2 right here. Right. 1 2. So this one 3, we start at 3, right? So we start at 3 somehow right here, right? So 3 12 36. So we start at, okay, let's pick this. Start at nums I here. See our chain. Right. So we're interested in number 3. Right. So what is it? I is 2, B is that, okay. So maybe we less than or equal is what we let it pick. We accept that equal, right? Right? Okay. So start at I here. So something we did it wrong. So we need to look at the value 3 here. -4. What? 0. Oh no, 2 here. 3. We accept them to be 3 here. And oh, we let the equal be, right? Because that could also make us so wrong. Okay, hold on. Okay, here, right? Why can't we? So we did not go into this. If not, or if there's some value and $24, this should have been 48 now. Yeah, we did go in here. Wait, no, this one. Right. It doesn't go into any of this, so some of the logic we have here is wrong. Right. Right, so something is wrong here. Start with 3. What is the value here right now? It's saying that P is 3, right? P, oh, what is this? Why is it 288? Oh, wait, hold on. Right, is 3, and if there is 1, yes, and the p multiplied by, what is this? Hello. Let's print them out and see. Here, hello. Oh, negative. Oh, wait, hold on. If there is a number and oh, it's negative, that's why. Okay, hold on. So this is the number, and the result we see here is we start at 3 because this is negative number. It's gonna give us negative, wait, hold on, negative 12, right? So I'm pretty sure if we don't do this and we just keep doing that, we should get the right value, but let's just see if the logic even works in the first place. Right, it does. So let's just submit this and see if it works. Right, I don't think so. Maybe time limit exceeded here because we probably have to do some sort of caching, which we got it with this, right? But let's see how it is. Yeah, it's probably limit exceeded. Time limit exceeded. Right. So we gotta figure out a way. Yeah. So like if we just use our stuff here, that could just give us a wrong answer, right? So probably the logic here that we have is probably wrong. Right. This does finish, right? See. Right. So the fact that it has the negative number. So at any point we either pick this or we start with this. Right. Right. So if we ended up somehow, right, you see here, wait, 288 is wrong here, right? Because just not put this case here first. We fix this one somehow, then we should be good. Right. Go and something like that. Let's print them out. What? Okay. Oh, we should also this. Right. Oh yeah. So we're looking at 24. This is the number that we think that, which is, how do we get 24? Multiply these together, right? Hold on. Yeah, 1 2 3 4. Okay. So that was the 24. But if we explore from 3, right, and multiply by 4, will only give us 12, negative 12, which is, but how do we know, like, something down the line gonna give us better, right? But if we do that, we got time limit exceeded, right? So 144, this is 432, right? This one, right? This guy right here, right? So we have a way to know that, we have to have a way to know, like, how do we stop the expansion, right? And then that should be good. It seems like this may be not the good way to do it, but I'll think about it now. So at any point, right, if we have so here's the number is, seems like two, right? Okay, so we have 1, negative 2, 3, 24, negative 3, 288, negative 3, right? So we start at 3, and we say that our early optimization is we doing this checking early, which is wrong, which is probably give us the wrong answer. We want to know let me see, is there a way to still doing the early checking as well as figure out what time is it? Probably spend 15-20 minutes, then I have to do grocery, I think. This is still raining right now. Oh no. It should be fine. Alright. We'll see how do we deal with this. So just giving wrong answer, right? So so let's look back at how do we get all the sub-array, I guess, and figure out a way to catch them. So either we have 0, 1, okay, 0, 1, 2, okay. So we have 0, 1, 0, 1, 2, 0, 1, 2, 3, right? And if the thing start at 1, we can have 1, 2, right? 1, 2, 3, right? And then 2, 3, finally 3, right? So that all the sub-array 1, 2, 3, 4, 5, 6, 7. Okay. So that basically 2 to the 3 minus 1 or what? Okay. Hold on. So 0, 0, 0, 0, 0, 0, 0, 1, right? So yeah, this is basically the number of subset, right? 0, 1, 1, 0, 1, right? 0, 1, 1, 1, right? And then yeah. Right, so is there a way after we scan for, okay, let's see, let's do one situation here. We got this, right? So 1 can go to -2, right? Okay, so that is 1, right? Or 1, it can start with 1, right? Which is -2, right? At every step. Let's go through with this number right here. So -2 go to 3, or basically 3 here. Okay, so the right subtree is a tree that starts with the number 0, 1, 2, right? So this is -1 multiplied by -2 is -2, multiplied by 3 is -6. So -4 here, right? 24, right? This is 3. So hold on. Okay, 0, 1, 2, 3, 4, 5, 6, 8. So we have 3 right now. -3. So this is right, and it's 72 negative. So make another -4. This make it 288. Right, and then the last number is -3. Right. This is 864. Okay, and then we back up and we fill them. This is -3, right, because this number is better. So basically these two numbers, and 288, -72, 24, and 3. Oh. Right. Yeah, 3, -2, 1. Okay. So the flaw we have here is we want to know at this point, right, if out of all of these, which one give us the best number, right? Right, if we right, so found, it sounds like this should be a bottom up approach or something, right? But I think I'll have to go grocery now. I'll come back for this a little bit later, maybe in 2 or 3 hours.